Today's number 3 most urgent vulnerability on the ranked list is CVE 2025-6965 in SQLite. And this one earns attention for a simple reason. SQLite is not a niche server sitting in one rack. It is a small database engine embedded inside countless applications, devices, services, developer tools, and mobile or desktop products. When a memory corruption flaw lands in a component that's widely embedded, the practical question becomes, where is it hiding in your environment? This is the Daily Ranked CVE Brief, What to Patch First, ranked by real exploitation signal from CIA KEV, First EPSS, and CVSS every day. CVE 2025-6965 is not currently on CISA's known exploited vulnerabilities catalog, but it has a very high EPSS percentile and a high CVSS score. So today we are going to keep this defensive: what the bug is, why it matters, how attackers might reach it conceptually, how to check exposure, and what to do now. CVE 2025-6965 affects SQLite versions before 3.50.2. The official description says there is a vulnerability where the number of aggregate terms could exceed the number of columns available, and that this could lead to a memory corruption issue. In plain English, SQLite can be asked to process structured database logic where internal counts are expected to line up. In this case, those counts can get out of sync, more aggregate terms than there are columns available for them. The associated weakness is CVE-197, which is commonly described as a numeric truncation issue. That family of weakness is about values being represented in a way that loses or mishandles information, which can create incorrect internal assumptions. Here, the security-relevant outcome is memory corruption, and memory corruption is serious because it means software may read, write, or manage memory in a way it was never designed to handle. The vendor recommendation is clear: upgrade to SQLite 3.50.2 or above. Verdict: this is a high-severity memory corruption flaw that deserves near-term patching wherever SQLite is reachable through applications or services. The CVSS score is 7.7, rated high. The two metrics to pay attention to are scope changed and high-integrity impact. Scope changed means exploitation can affect something beyond the vulnerable component's normal security boundary. In operational terms, that raises the concern from just a local database library issue to a broader application impact issue. High-integrity impact means the most serious rated consequence is not just seeing data, but potentially altering trust, state, or behavior in a meaningful way. The vector also includes high attack complexity, which is important context. This is not being scored as trivial to exploit. But high complexity does not make it safe to ignore, especially for a component that may be deeply embedded in applications and hard to inventory after the fact. CVE 2025-6965 is not currently listed in CISA's known exploited vulnerabilities catalog. That matters. KEV listing is one of the strongest public signals that exploitation has been observed in the wild. But not being on KEV is not the same thing as being low priority. The EPSS percentile provided here is 0.99397, which places it extremely high relative to other vulnerabilities in terms of predicted exploitation likelihood. Combine that with SQLite's deployment model, and you get the real risk. Defenders may not know every place SQLite exists in their environment. It can be bundled inside commercial products, included with internal tools, shipped as part of mobile and desktop software, or indirectly present through dependencies. Memory corruption issues also tend to attract security attention because the failure mode can be more dangerous than a simple application error. So the practical stance is measured urgency. Do not claim active exploitation without evidence, but do not wait for a KEV listing before inventorying and updating. A key point: SQLite is normally not a standalone network database server. So when the CVSS vector says network attack vector, defenders should think about the application that embeds SQLite and is reachable over the network. The path is usually indirect. An application receives input, transforms it into database operations, and SQLite processes those operations locally. If low trust or attacker-controlled input can influence the kind of database work being performed, for example, through reporting features, search, filtering, synchronization, import workflows, analytics, or other application logic, then the embedded SQLite library can become part of the attack surface. We are not walking through exploit steps or payloads here. The defensive takeaway is to map where external or low-privilege users can cause complex SQL processing, especially processing involving aggregate behavior. The CVSS vector also requires low privileges and no user interaction, meaning the scenario does not depend on tricking a separate human into clicking something. Your exposure depends on how your applications expose SQLite-backed functionality. To check whether you are affected, start with version inventory. The official description says SQLite versions before 3.50.2 are vulnerable, and recommends upgrading to 3.50.2 or above. That sounds straightforward, but the hard part is finding every copy. Look beyond obvious package installs. SQLite can be statically linked, bundled with applications, embedded in appliances, included in containers, or shipped inside third-party software where your operating system package manager will not tell the whole story. Use your normal software inventory, dependency scanning, SBOM data, container image scanning, endpoint telemetry, and vendor asset records to locate SQLite usage. For internally developed applications, confirm which SQLite library is used at build time and which one is actually loaded at runtime. For commercial products, check the vendor's advisory or release notes for their exact fixed builds. Do not assume that the presence of SQLite somewhere on the system means the application is using the patched copy. The safe exposure question is, can any production code still load SQLite before 3.50.2? The primary remediation is to upgrade SQLite to version 3.50.2 or above, exactly as the official description recommends. Prioritize systems where SQLite is reachable through network-facing applications, multi-user applications, or services where low-privilege users can trigger database-heavy operations. If your software statically links SQLite, updating a shared library on the host may not be enough. The application may need to be rebuilt and redeployed with the fixed SQLite version. If SQLite is bundled inside a vendor product, track the vendor's fixed release, rather than trying to replace internal components manually. While patching is underway, apply sensible hardening. Limit who can access high-risk application features. Validate and constrain user input at the application layer. Reduce unnecessary report or import functionality for untrusted users if you can do so safely, and keep crash reporting enabled. Also make sure backups are current and restorable, because the rated integrity impact is high. Patching is the fix. Hardening is the safety net during rollout. Detection for memory corruption is imperfect, so do not treat monitoring as a substitute for updating. But it can help you catch signs of stress while you are inventorying and patching. Watch application logs for crashes, restarts, abnormal termination, or repeated database errors around features that perform aggregation, reporting, filtering, search, imports, or analytics. Look at process supervision data for services that restart unexpectedly after handling requests. Security tooling may also surface memory violation alerts, unusual faulting behavior, core dumps, or endpoint detections tied to the affected application process. On the application side, establish what normal looks like: typical request volume, expected SQL error rates, normal reporting patterns, and normal latency for database-heavy endpoints. Then look for spikes or clusters that do not match user behavior. For internet-facing services, correlate errors with source patterns and account activity, but avoid jumping to attribution. The goal is practical triage. Identify exposed applications, spot instability, and accelerate patching where evidence suggests the database layer is being stressed. Quick recap. CVE 2025-6965 is today's number 3 most urgent CVE on our ranked list. It affects SQLite versions before 3.50.2, where aggregate terms can exceed available columns and lead to memory corruption. The score is 7.7 high, with change scope and high integrity impacts standing out. It is not currently on CISA-KEV, but the EPSS percentile is extremely high, and SQLite's embedded footprint makes inventory the real challenge. Your action plan is simple. Find every SQLite copy, confirm whether anything before 3.50.2 is still in use, prioritize exposed applications, rebuild or update bundled copies, and monitor for instability around database-heavy features. If this brief helped you decide what to patch first, subscribe to the Daily Ranked CVE Brief. We rank the day's vulnerabilities by real exploitation signal, CISA-KEV, first EPSS, and CVSS, so teams can focus on what matters first.